In this video here, we will look at solving trigonometric equations but using general solutions for the function of tan. Usually for general solutions, we will not be given a domain where our domain is actually from negative infinity to positive infinity. So what this means is that we will need to find every single solution along the way, and to do that we just need two solutions and then show the repeated process. Our first step here is to rearrange the equation. So we are going to rearrange this root 3 by dividing by root 3 here. And in our next step we will rearrange the tan, so it becomes tan inverse of 1 over root 3. Once we have this, we will take our unit circle to investigate this further. And what we will have is we are looking at a gradient of 1 over root 3. So a gradient of 1 over root 3 is not perfectly diagonal. It's slightly less than that. And this is when the gradient is positive. The angle that's associated with this value here is pi on 6. So our two solutions that we have here is pi on 6 and 5 pi on 6. But if you have a look here, if we want to get to our same solution, again, we can add pi on 6. But if you notice, to get to the next solution, all you have to do is add pi. So this changes the period a bit for sine and cos. Sine and cos, to get to our next solution, we need to add a full rotation of 2 pi onto it. But for tan, we only need to add on a period of pi. Now, seeing that our denominator for our solutions is pi on 6, we can rewrite pi as 6 pi on 6. So when we go to our general solution now, we only need one solution. So let's pick our easiest one, which is pi on 6. We're going to add the period on, which is 6 pi on 6. And we can add that on a certain amount of times. Now this is an x here, it's actually 3x. N is an integer. So if we want x now, we just need to multiply 3 in the denominator. So we get 6 pi. I'll write this as 6n pi. I can just take this n into the numerator over, multiply by 3 in the denominator. It's 6 times 3, which is 18. I'll merge that now. Under one denominator, it becomes a lot easier to churn out the solutions. Now, if our question was find the first 3 negative solutions of this equation, we can start off at 0, but if we start off at 0, we will end up with pi on 18, which is not what we want. But in any case, I'll do it anyway, just to show what solutions we can get. Pi on 18. If we let n is equal to, now we want our negative solutions. So if we let n equals to -1, we will get -6 pi here. -6 pi plus pi is -5 pi on 18. That's our first negative solution. Let's see our second negative solution. If n is equal to -2, this term here becomes -12 pi. negative 12 plus 1 is negative 11 pi on 18. And last but not least, for our third negative solution, if we let n equals to negative 3, we get negative 18 pi. Negative 18 plus 1 is negative 17 pi on 18. So our first three negative solutions will be negative 5 pi on 18, negative 11 pi on 18, and negative 17 pi on 18.